Okay, let's get started. This is project 2 in xfoil. Let me share my screen. So here we go. Here's the project information. There's 3 parts. First part, we're testing out 3 different airfoils, a NACA 0015, a NACA 2415, and then a Clark W airfoil, which we got from the University of Illinois, which I have open right here. I just copied all of this into a text file. Then you need to import that into xfoil, which I will talk about in a minute. And then part 2, we're testing out Viscous Flow, Laminar Flow, and Turbulent Flow on the Clark W airfoil. And part 3, we're also sticking with the Clark W airfoil, but we're testing out different degrees of flaps, all turbulent flow. So the first thing you want to do is have xfoil downloaded, and you want to copy the executable application into a new folder, a dedicated folder, just to keep all your files organized. As you can see, I've already done all the parts before this video. And right here, Clark W, this is the airfoil right here. All you do is just you copy it into a text file. And I'm going to re-record part 3, the angle of 20 for the flap for this tutorial. So let's get started. Let's open up xfoil. When you open it up, you're going to get this screen right here. Now, the first thing you want to do is either enter your NACA airfoil, whatever number, but I'm going to load my custom airfoil, not the one we have to use. So you want to type load space and then type the file name clarkw.txt, hit enter. And you can see the airfoil popped up. We have 33 panel nodes. Let's just move that over here. Okay. And the next thing you want to do, something I found out, is you want to do the geometry first. You want to do your GDES before you do your PPAR. For whatever reason, it just seems to mess up on my computer. I don't know if it's just a my machine thing or everybody else, but we're going to do our geometry first. So you type in GDES, hit enter. Now we're in the GDES command window. So you can see that this changes it now, and we can see our airfoil here. So first thing we want to do is we want to add a flap. So we're going to type in flap, and now we can enter our hinge location. I'm going to put in 0.7. Enter that. I'm going to specify y over t. So you hit 999, or you can just enter your hinge y location. And let's go with 0.5. And what this means right here is the y over t location specifies half of the thickness of the airfoil. So 0.5, enter, and now we have our flap deflection in degrees, and we're going to do a flap downward in the downward direction, and that makes it positive when we enter it into xfoil. So if you wanted to have a flap that went upwards, you would, let's say you have a 15-degree upward, you would type in -15. But we're going to do 20 degrees downward, so we just type in 20, enter, and now we can see it highlights our new airfoil in purple, and our new information here in purple. And to save this, you're going to execute it, and the command is exec, enter, enter again to go back to the xfoil window, and now we want to smooth this out. So we're going to type pane, okay, and then we want to type ppar. What this does, this opens up the paneling, or I'm sorry, the paneling parameters command, and we can see our window over here has changed again. You can see all the panels over here, and we have our angle. So what we want to do here is we want to change the number of panel nodes. Right now we're at 160. I'm going to change it to 350. And we also want to change our TE/LE panel density ratio. Where now it's at 0.15. I want to change it to 1. So to change our panel nodes, we're going to type in N space, and then let's do 350. Enter T1, enter, enter again to save it. There we go. You can see now here our number of panel nodes is 350, and our new density ratio, panel density ratio, is 1. Okay, now we're going to hit enter again. And we're back in our xfoil command window. And now we're actually going to do our operations. And in order to actually do the operations, you type in oper for operations. And now we get this command over here, .oper I. This I here means inviscid. And we want to get a viscous flow. So we're going to type in VISC. And now we need to type in our Reynolds number. We're going to type in 1 million. We want a turbulent flow. And now you're going to see Mach number is 0. Here, don't worry about Mach number. Mach number is not going to matter. It's not going to change anything for this. So just leave it as is. And now you can see our Oper I has changed to Oper V, V for viscous. So we're good to go there. Now let's change our iterations. The default is 10. We want to change that. So type in iter and type in your new limit. Let's do 1000. All right. All right. So we got our new Reynolds number in there. We got our new iteration limit in there. I think we're ready to go. But before we get started, we want to make sure that we're recording what we're doing. In order to do that, we're going to type the pack command. That's PACC. And that creates a file where it saves all the data. So now let's type in a name. I'm going to name this part 3 underscore 20 underscore 2 because I've already done it once and I wanted to save it as a separate file. And now it's going to ask you to put a polar dump file name in there. I wouldn't mess with that. I tried messing with that and it just crashed every time. So we're just going to leave that blank. And now you can see our command is oper VA, V for viscous, A for accumulation because it's accumulating the data. So, all right, let us get started. So we can type in, we want to get all the polar data, SEUP. That will bring up the graphs in this other window right here of the polar graphs, but I want to see the airfoil. So we're going to type in the command ASEQ, and this will go through the ranges of the angles of attack that we need. And we're going to go through we're going to go from -5 to 15 with a step of 1. So you want to enter first your lowest value. So I'm doing -5, but if you want to start from an angle of attack of 0, you just put in 0. You put your maximum next, and then if you want to go up by half a step, put in 0.5 or just whatever step you want. Hit enter, and then it's going to start doing the calculations. Okay, there we go. So it has finished its calculations, and I love this graph right here. This looks awesome. It's just so satisfying to see. So we can see here, point written to save file. We have our save file here. So I'm gonna hit PACC to end the saving. Now let's see. Here it is. Right here. Let's view it. So for whatever reason, our alpha of -5 is not saved. So since we have it right here, I think I can just manually put it in. Let's mess it up. So I'll move this window over. Back up. Let me see. Okay, so it does decrease. So I was inputting everything into MATLAB. I'm gonna add it anyway. So that's the basics right there. One thing I do want to say is this extra window that pops up. Don't minimize it because then it gets finicky and the program doesn't like it when you minimize things. Another thing is if you don't need to change the geometry, if you don't need to add any flaps or slats, then you don't have to worry about the GDES there at the beginning. That'll just be pointless. You'll just open the window and then close back up again. The P part is important though. You want to make sure you have a good number of nodes. Am I missing anything? If you just want to change, if you don't want to go through a range of angles of attack, the command is ALFA, alpha, and then you enter whichever one you want, -5, and then it'll go through your iterations. I meant to change the other thing, the SEQP changes to polar. That changes this window. All the values are the same. I did them both side by side, and all the values come out to be the exact same. So that just changes this window to a graph. And that's it. To quit out of here once it finishes converging and to get back to the .oper_v, just hit enter again to get back to your xfoil command and then type quit and it'll close out the program for you, or you could just click the red X. But yeah, you want to make sure that you look at what command window you're in, because you don't want to be working in, let's say, PPAR when you're trying to do GDES. You want to make sure you're typing the right commands into the right under the right subroutine, or the subroutines under the right command. So there we go. I think I covered it all. I think that's all I wanted to cover. Because I think part 3 really hit everything. Like I said in the beginning, you just type in a different NACA right from the beginning. You can take your text files, import it into Excel or MATLAB. I chose MATLAB for my graphs, import it in there, and you can make it look nice. Um, what else? What else? What else? Yeah, to get laminar flow, you just enter your different Reynolds number. Once you get in there and type into the operations and type VISC, and it prompts you for your Reynolds number. You change that there. If you want to change it again, you just type RE, and it'll prompt you to change your Reynolds number. Okay, it failed to converge, so that's why. Okay, so yeah, if you want to change your, just type RE, and it'll say what it currently is, and then you can change it. Change back to RE again. There we go. So we can change, if we want to change our iterations, we just do that again. 500. Maybe it'll converge if I do more. Who knows? All right. I think that covers the basics. So yeah. Then it's up to you to tabulate your results in Excel or MATLAB, whatever you choose.